A Kubernetes pod can log into cloud APIs without carrying a secret. The trick is that the service account token Kubernetes already projects into the pod is an OIDC token with an issuer, a subject, an audience, and a signature the cloud can verify. Once the cluster publishes issuer discovery and a JWKS, AWS, Google Cloud, or Azure can treat that pod token as proof of workload identity and exchange it for short-lived credentials. That means no static AWS key in a secret, no service principal password baked into an image, and no node-wide IAM role shared by every pod on the machine. Same pod, same Kubernetes service account, different relying party. By the end of this guide, you will see why projected tokens, OIDC Federation, and pod identity are really the same trust chain wearing different product names. In this guide, how Kubernetes turns a service account token into an OIDC issuer the cloud can trust, where EKS pod identity, GKE Workload Identity Federation, and Azure Workload Identity differ, what the token exchange looks like on the wire, and which mistakes break pod identity in production. Identity expert, powering you to be an expert in identity. Think of a conference badge that works in your building and a passport that works at a border. Inside the conference venue, your badge proves which company issued it, which person it belongs to, and which rooms you can enter. But if you take that same badge to an airport, the airline does not know your company or trust its badge printer. It needs a document format and a trust path it already recognizes. Kubernetes service account tokens used to be like the first badge, useful inside the cluster, meaningless outside it. OIDC issuer discovery turns the cluster into a recognizable passport office. The cloud does not need to know your pod ahead of time. It only needs to trust the issuer, validate the signature, check the audience, and map that subject to the cloud role or identity you authorized. 4 technical problems explain why pod identity exists. First, workloads need identity outside the Kubernetes API. A pod might call Secret Manager, S3, Key Vault, or a partner API that has never heard of Kubernetes RBAC. Second, node identity is too coarse. If every pod on a node inherits the node's cloud role, one compromised pod can laterally move into another team's permissions. Third, static cloud secrets are operational debt. Access keys, JSON key files, and client secrets leak into images, config maps, CI logs, and laptops. Fourth, legacy service account tokens were the wrong shape for federation. They were long-lived and not always audience-bound, so a token meant for one relying party could be replayed elsewhere. Bound projected tokens plus OIDC discovery fix all 4. The pod gets a short-lived JWT. The cloud validates issuer and audience, and authorization happens on the narrow workload identity you actually intended. Here is the trust chain end-to-end. Step 1. The kubelet mounts a projected service account token into the pod. That token is minted by the Kubernetes Token Request API, signed by the cluster issuer, and bound to a specific audience. Step 2. Either the workload's SDK or a node-side agent presents that token to a cloud security token service. On GKE and Azure Workload Identity, the workload exchanges it directly. On AWS IRSA, the SDK calls STS with assume role with web identity. And on EKS pod identity, the node agent performs the exchange through the EKS auth path. Step 3. The cloud fetches the issuer metadata and JWKS, validates the JWT signature, checks issuer, audience, subject, and expiration, and confirms you created an explicit association between that Kubernetes service account and a cloud role or identity. Step 4. The cloud returns short-lived credentials or an access token, and the workload uses those to call the target API. On the wire, the pattern always reduces to 2 HTTP hops. First, the workload exchanges the projected Kubernetes token with a cloud identity endpoint. In Google Cloud, that is the security token service. In Azure, it is the Microsoft Identity Platform token endpoint with a federated credential. In classic AWS IRSA, it is STS assume role with web identity. EKS pod identity hides that first hop behind a node agent, but the trust check is the same. Validate issuer, subject, audience, and association. Second, the workload uses the return bearer token or temporary credentials to call the target API. Notice what never appears in the pod: no static access key, no long-lived refresh secret, and no generic node role with broad blast radius. The Kubernetes token proves who the workload is. The cloud token proves what that workload is allowed to do for the next few minutes. 3 mistakes quietly destroy pod identity. First, wrong audience or overbroad trust. If you mint tokens with a generic audience or trust every subject from the issuer instead of one namespace and service account, a token meant for one relying party can be replayed at another. Second, stale credential paths. If your pod still has static cloud keys and environment variables or a mounted secret, the SDK may use those before it ever tries the projected token path. Third, stolen projected tokens. A projected token is short-lived, but while it is valid, an attacker who can read the file can still attempt an exchange. The mitigations are straightforward. Mint audience-bound tokens, scope trust to the exact subject, remove legacy credentials so the intended provider chain wins, rotate tokens aggressively, and constrain the returned cloud role so a single workload token never unlocks more than one narrowly defined task. The direction of travel is clear. Kubernetes bound service account tokens and issuer discovery are now normal cluster plumbing, not an edge feature. GKE Workload Identity Federation for GKE treats this as the default path for Google Cloud API access. Azure Workload Identity replaced the older pod identity interception model with native projected token federation. OZ now offers both IRSA and EKS pod identity, but both still depend on Kubernetes proving workload identity to OZ. The next layer is interoperability. SBIFFE and Spire solve workload identity across platforms, and the IETF WMSE effort is standardizing how workload identifiers and proof profiles survive across trust boundaries. That is the big picture. Pod identity is Kubernetes' native workload identity. OIDC is the bridge that makes it consumable by cloud IAM systems. Once you see that, vendor naming stops being confusing. You are looking at one architecture expressed three different ways. The primary Kubernetes and cloud references for this guide are on screen now. Kubernetes Service Account Administration, RFC 8693 Token Exchange, and the official OZ, Google Cloud, and Azure Workload Identity documentation. Thanks for watching. Subscribe to Identity Expert for more deep dives into workload identity, zero trust, and IAM architecture.